Welcome to the Cold Working Shop. In today's video, I'm going to be lapping and polishing the hexagonal murrine that I assembled in the last video. And by the way, I got a new wireless microphone system. The first one that I had was a kind of an El Cheapo, somewhat no-name Chinesical unit, and now I've got a Sennheiser, so hopefully quality equipment will produce excellent results. I'm going to be using my experimental prototype lap wheel here that is nowhere near ready for production. I know that people have asked, hey, I want one, can I buy one? And it's obvious by looking at it that it's a first generation prototype, but might as well talk about it a little bit. It's a 12-inch lap wheel that uses standard 12-inch diamond discs, nothing special there. I do have center mounted, turn the water on here. I do have center mounted cooling, which is a kind of a nice feature. And what makes it different from other lap wheels is the attachments. At the moment, I have this attachment, which, as you can probably see, is a very crude early prototype. And the idea is that it's got a plastic cup with a rim and an O-ring, and it's connected through a hose to a water separator, so if water ever does get in, it doesn't get into the vacuum pump, and then down to the vacuum pump. So the vacuum holds, let me get a little water in the O-ring there. The vacuum holds the workpiece in place, and then the little gear motor here rotates the part as it's being lapped on the lap wheel. The attachment mechanism here is designed to do a bunch of other things other than this particular geometry. I've got a standard ER20 collet here and stainless ball bearings that allow it to rotate. And then on the back, I've got an indexing scheme currently with a 12-position index, but eventually this thing could evolve into a faceting machine. It could evolve into a variant of a faceting machine that's not quite a fastening machine, but something else. So it's very definitely an experimental R&D work in progress, but for what it does, seems to work exceptionally well. So the part that I'm going to be working on here, let's see if you can see it here on the little GoPro. Came out reasonably well. I had some problems with one of the triangles cracked in the kiln, and there were some other instances of trapped air, but in the process of fusing it together, it appears that I've corrected, maybe not perfectly corrected, but more or less corrected all of the problems. And so I think I'm ready to go here. I'm going to put the piece in place. The first time it sticks, the surface is somewhat imperfect. It's not quite as nice as I'd like, so the very first time that it's used is always just a teeny bit scary. So I'm going to just verify, because I don't want it coming loose. I'm going to verify, and yes, it's stuck down real good. The paddle method, using the hand torch and the special reinforced paddle, the paddle method does a pretty darn good job of flattening the surface. It actually does an excellent job of flattening the surface. So for the first grind, I'm going to be using a 100 grit metal diamond wheel, and I'm going to set my timer here for 1 minute and give it just a little bit of water. You don't want to use too much water on a diamond wheel, or the part starts hydroplaning and you don't get very good grinding action. So, up, over, into place. Got a 5-pound weight that I cast, and then I start the timer. I actually did some experiments on the previous one where I would grind for a minute, measure with a caliper, grind for a minute, measure with a caliper, and I've determined that 1 minute of grinding on the 100 grit wheel results in a material removal of about 10,000ths of an inch. And on this particular piece, I need to, well, the piece started out as 300 thousandths, and my final size will be somewhere around 150, 170, somewhere in that neighborhood. But I need to grind off the surface, not only, I'm watching my timer over here. Okay. Weight off. Lift up, flip over, vacuum off. Wow, it's looking better already. When I was fighting the cracks and the air bubbles and just trying to recover from all the problems, I was somewhat skeptical about this piece, thinking that it was not coming out very nice, but now that I see the result, might actually be very nice. So when I fuse it using the hand torch and the paddle, I necessarily degrade the surface and smear the surface. There's a little bit of boiling, a little bit of overall scuzz. It's not a very nice surface. So I need to grind away enough of the surface to flatten it, hopefully get through the surface bubbles, but of course, you know, sometimes I get through a surface bubble and just expose a surface bubble. So, you know, there's no winning these bubbles. The bubbles are winning the war. I gotta fight harder. Anyway, the second, and I always check when I'm turning over, so that especially when I'm talking and trying to pay attention to doing a video, I don't actually accidentally forget to turn on the vacuum pump and end up losing my piece. So yes, it is securely fastened. I don't see any water in the water trap, so it means that there's no holes in the piece at the moment, although as I grind I may end up exposing one. But so this side I will grind for 3 minutes. And for those who are interested, this custom-made 5-pound lead weight is a piece of a mild steel square tube with a prong mounted, or not a prong, with a plate mounted on, welded on the end. And then I got a lead ingot and kind of like held it in the pliers and used the glassworking torch and dripped in the lead and got myself a nice 5-pound weight. So the motor is on a Chinese eBay El Cheapo gear motor, DC gear motor, 12 volts. I made this little cap for it because originally it just had exposed leads, and well, that's no good. And, you know, some of the parts are stainless, some of the parts are aluminum, some of the parts are mild steel. All the mild steel parts are rusting, and as I use this more and refine the design of the prototype more, the next generation, everything will be stainless, everything will be, all the aluminum parts will be anodized, and I'll probably put a little cover over that belt, although it doesn't look like it's real easy to get a finger caught in it. You never can tell. So just going along, grinding away, and I actually made a plan for what I'm going to do, because I kind of bit myself and I kind of shot myself in the foot a couple of projects ago. I kind of halfway remembered, wow, this is taking a long time. Seems to take forever to do this. So on the next one I did after that, I just kind of turned it on, forgot to set the timer, went away and did something else, and then came back and it's like, where'd my piece go? It was ground down to like 1/10 of an inch. And of course it's still usable, because when it's framed in the sculpture, nobody knows how thick it is and the pattern looks great. But now I'm being careful, I'm planning, and that applies to pretty much everything I do in glasswork and machine work and prototype development. Start out fast and sloppy and approximate and by guess, and close enough is good enough, and then little bit by little bit refine, tweeze, tweak, perfect, and then finally end up, chasing that last 1,000th of an inch. So coming to the end of the 3-minute cycle here, remove the weight, rotate. Ooh, that's looking nice. And yeah, unfortunately it still has some air in it, but hey. So that's what it looks like at the moment. So I'm going to flip it over, roughly center it, make sure to turn the valve on the vacuum pump, verify that yes, it is stuck and stuck but good. Since I've already given it 1 minute in the preparatory grind, setting this for 2 minutes, so I'll end up with a total of 6 minutes, 3 minutes a side, 30 thousandths per side, for a total of 60 thousandths material removal. Then the next in line, I'm going to be using the brown pad, which is a 325 grit. I believe this is what they call a polishing pad. It's not metallic, it's some sort of resin bond pad. And yes, in case you're wondering, the little metal pad wheel holder is also something I made in the shop. And boy, it's great to have a shop. People who don't have a shop have to pay $300 for this. Not that, the guy who's selling it for $300 is ripping you off. I mean, he's got to make it too. But it's just really cool to be able to say, oh, I need one of these. I think I'll just go out in the shop and whip it out. Well, using a Harbor Freight vacuum pump, and I'm going to talk a little bit about the water trap. When I first started doing it, like I was saying, first time through, quick and dirty, rude and crude and approximate, close enough is good enough. I just hooked up the vacuum hose to the vacuum pump. And well, I ended up polishing one of my sections that had a hole in it. And the water got into the vacuum pump. And I noticed, why is the vacuum pump kind of overflowing with this kind of weird, scuzzy looking, disgusting, foul, milkshake kind of ooze coming out of the vent port? Okay, that's what happens. So now, this is just a standard a polycarbonate water filter housing that holds vacuum really well, works with the vacuum pump really well. I don't need to turn the vacuum pump off for this. I'm not flipping, so I'm going to this and go over to the brown pad. I've run into some differences of opinion as to proper polishing strategy. So before I get into that discussion, 1 minute per side, had to look at my notes here, 1 minute per side on the 325 grit brown pad, which is still rather aggressive. In woodworking, which is my background and where I'm a lot more familiar, I was a woodworker for many years, owned a cabinet shop and made many complex wood projects. In woodworking, you go through the grits. You sand with one grit, then go to the one below it, sand out all the scratches produced by the previous grit, drop a grit, repeat, rinse and repeat, and until you get your scratches down to a size that you believe is acceptable. Some glassworkers have suggested, well, do that with lapping. Get a wheel of, or a disc of every possible grit that is offered and go through them one by one by one by one by one. Other glassworkers say, you know, you don't really need to do that. You can just, some guys say just use the brown pad and go straight to cerium. Other guys say, well, if your surface is really, really rough and it needs a lot of work, okay, use the metal pad. I've been experimenting with both methods and have, since I do have the full set of pads, I'm able to do the experiment. And I've kind of come to the conclusion for my own work, based on my own experiment, that the 100 grit metal, the 325 grit polishing, the 600 grit polishing, and then go to cerium. Okay, got to remember to pay attention while I'm talking here and make sure I get this right. Now, at the moment, it just kind of sits in the position it's at. I've thought about, well, wouldn't it be cool if I could make it oscillate and even out the wear along my pad? Because right now I'm just wearing a groove in the pad and it's probably going to compromise my pad life. So I've been thinking about how to do that without adding an outrageous amount of complexity and figuring out how to get it all to fit and keep it all waterproof. And yes, it's a wet machine. Water gets everywhere. It's a real mess. That's why it's out in the cold shop, outdoors. So, looking at the timer, watching. And that is the end of that. Pull out the pin, rotate, power off, water off, rotation off, vent the vacuum. Design's actually looking nice, and if it wasn't for the trapped air, I'd be a whole lot happier. I think just in general, I mean, no part of the project, no part of the process is perfect yet. I'm still learning, but definitely the weakest part of the work is the hot assembly where I trap air. So, vacuum pump on, rotation on, verify, secure, holding. Going to be 3 minutes per side on the 600 grit. The 600 grit really, it doesn't when I measured with calipers, it was hard to really tell how much was being removed with the 600 grit. It actually doesn't do any bulk material removal. It obviously gets rid of some of the scratches left by the 325 grit, but it doesn't really reduce the thickness of the piece anymore. So that's about it. As the design progresses, I'll probably put a guard around that belt. But like I said, early designs, cheap and dirty. And probably add more waterproofing down here to keep the water out of the motor. The bowl, in case anybody is wondering, the bowl is a stainless bowl from a kitchen supply. It's a salad bowl and seems to fit perfectly. I mean, it's a really nice bowl, and it kind of looks cool, maybe. Of course, there's always a question that comes up when designing something like this. If you make the rim of this kind of the bowl or the structure that surrounds the wheel, if you make the rim really tall, then you get very little splash out, and you don't get like stuff all over the walls and stuff all over the windows, but it also makes it more difficult to get in. So you probably noticed that I've cut out a slot in the side of the thing here so I can get various different tools and fixtures in through the side. If I would have raised the disc to the point where it was even with the top of the bowl, well, then I'd have a big mess everywhere and I'd be covered with water, and probably wouldn't really like that much. So just continuing along. Getting a little low on the cerium here. I might have to go mix up some more. But there's another question when considering the possibility of turning this into a commercial product. I kind of always ask myself, is it already a solved problem? And let me get this taken care of here. Got to balance talking and working. So, flip it. Flip it good. Ba-na-na-na-na, make sure that it's solidly in place. Not going to fly out. It really sucked to have it fly out. So, timer on. Weight is in place. Back to the philosophical discussion. The question is, I mean, it's a number of questions that all kind of overlap on top of each other. First of all, I'm a one-man shop. I only have time for a certain number of things, and even though I'd love to do everything, well, I don't have the time to do everything. Second of all, if a commercial product already exists, I'm not going to sell another one just for the purpose of competing with it. If this was just a lap wheel, I'd say why bother? There's lap wheels out there. You can buy them. They're good. The companies are good. The only reason that I would consider commercializing the lap wheel or the wet saw is things like my fixtures, things like the vacuum chuck and the indexing head and whatever other bizarre, who knows, CNC glassworking stuff that I may cook up. That doesn't exist yet. And so if I came up with a reasonable product that was perfected to the point where I could be confident in selling it, and it was the only one of its kind in the industry, then I'd consider selling it. So, you know, a question has come up, well, are you going to make a glass lathe? Probably not, because, you know, they exist. Unless I could come up with a revolutionary new glass lathe, I wouldn't do it. The NQALHA, it is one of a kind. It's the only one of its kind, and there are no others like it, so it's fine. Of course, I've got crazy ideas if I can figure out how to synchronize two of them and have a quick disconnect that they'll mount on a linear rail and move back and forth. Hey, now I've got a lathe. So, yeah, you never can tell what happens in R&D. Okay. Kind of running out of things to say here. So, might as well talk about the weather. It's been cold here out in the cold shop, and I don't like the cold. Some people are polar bears. I'm kind of a desert rat. I'm fine in the hot, and I don't like the cold. So my answer, insulated pants. I found insulated pants, and wow, it solved the problem. I'm not cold anymore. Of course, that's insulated pants, long underwear, 3 layers of clothing, and, you know, all like that, but still, for anybody who's cold working outside or they're working in an unheated shop, insulated pants. So there we go. 3 minutes are up. Yeah, many things about that design came out pretty nice. I'm happy with a lot of it. So the first thing I do is saturate the cerium pad, then turn the water down to almost nothing. Shake up my little squirter, get a little on, make sure the vacuum is still okay. Up and over. Going to be polishing with cerium for 5 minutes. Which is even more boring than watching paint dry. And yeah, it looks like the cerium has a little bit more friction. Kind of wiggling around a little bit. I don't believe it's a problem. Of course, I don't really like it. I don't like wiggling around, because in some things, if your machine is wiggling, it means you built it wrong. So, and once again, this thing was not designed using proper engineering analysis. It was done by intuition. It was done by, hey, that looks good. Close enough is good enough. Just about nothing more boring than watching the machine work. And of course, like I said, the last time I got bored, walked away and did something else, lost track of time, and ended up over-grinding my piece. So walking away when bored is not a good strategy when you really should be paying attention. Of course, if I was really fancy, the whole thing would be CNC, and the machine would just, at the end of the cycle, it would just lift up and move over and put itself down and automatically shut itself off. But, oh, that's way too much trouble. This thing seems to work pretty good. Simple is often better. Which of course brings up a philosophical rant. You know, you probably know by now that I like to rant. Boy, I like to rant. That some people believe a design is finished when you can't think of anything more to add. I take the opposite approach. I say the design is finished when you can't think of anything more to remove. Minimal is best. The minimum number of parts, the minimum amount of complexity to produce the desired result. What I like. And then on the topic of bubbles, I look at an air bubble in a piece like this and think, oh shit, that's a failure. I screwed up. I'm an idiot. I have no skill. What am I going to do? And who knows? There may be somebody out there that goes, wow, that's a really cool little crater, dude. How'd you put that one in? I don't know. Okay. We are nearing the end now. Can you feel the excitement? Verify that it's stuck in place. Start the timer. Add some juice. And boogie till the cows come home. I don't think the cows are ever going to come home here. I don't think it's their home. I think they live down the street. Now here's a question that I'm not quite sure of. How often do you juice it with cerium? I don't know. Do you juice it once and then polish, or do you keep juicing it constantly? Or, you know, cerium is expensive, and I don't know. I got to look into that. I just do it kind of here and there, kind of when it feels right. Crudely and approximately on a non-uniform random schedule. Although, you know, that being said, it's impossible for a human, even when they try to be random, to be truly random. It's impossible. Humans can't be random. Even if you try as hard as you can to be random, you can't be random. The mathematical tests of randomness will always show a systematic behavior on anything ever done by a human, if they're trying to be random. If they're not trying, if it's something like, you know, eye blinks or something like that, then there probably is some randomness in it, but probably also systematic. It's incredibly difficult. Scientists who study this, computer scientists who study this, find that it's incredibly difficult to generate true randomness, especially with a computer. So a lot of computer software uses things like the time in microseconds between key presses of a human on a keyboard, or they'll have a special circuit with a noisy electronic component and use electronic noise to generate randomness. The most sophisticated random generators use quantum effects, but there's some debate on, well, yeah, we all know quantum is 100% random, don't we? Yeah, we think we know. We're sure we know, but we think we're sure we know. The deeper you dig into stuff like that, the more uncertain you become that you know anything. What is random? Does random even exist in the most random of processes? course, here's an age test for all you old-timers. Anybody used to listen to the Firesign Theater, where they had an episode of a radio drama called Police Street, where the detective was, I think it was Lieutenant Random Cool Zip. Memory is weird. Why do I remember these things? Shoes for industry, shoes for the dead. Hi, I'm Joe Beats. So take off your shoes for industry, which actually was the name of a band I was in, Shoes for Industry. We weren't very good. So that's it. The piece is complete. I still have no idea what I'm going to do with it. The three possibilities are, I can put it in one of my sculptures, which I'm reasonably confident that I'll succeed at because I'm a whole lot better as a woodworker and metal worker than I am as a glass worker, and my wood and metal stuff almost always comes out really, really good. The mistakes are so small that almost nobody can see them unless I show you exactly where they are. So I could make a sculpture. I could give it to a glassworker and see what the other glassworker could do with it. And the third thing is I could attempt once more to fuse it into a piece of glasswork, to try to put it in the bottom of a drinking glass or on the surface of a bubble of some sort. And every time I've tried this in the past, I've failed catastrophically, but hey, you know, if I don't keep trying, I'll never get it done. So I don't know what I'm going to do. But I do know I'm going to turn the camera off. So thanks for watching. It's been fun.